Course 3, in this lesson we are rounding and estimating. Normally math is all about getting the exact number, but when we round or when we estimate, it's about getting close to the right number. So keep in mind when we do problems that the book tells you to round to a place or to estimate the value, you really shouldn't be just calculating the correct amount, but you should be mentally getting to, without the help of a computer or calculator, what about is the answer? I know about doesn't seem like a right answer, but if it asks you to estimate, then it is. When we round, we're finding a nearby number that ends in a 0 or more, so it's a nice and clean number. If we have 188, you can round that a few ways. It's going to round up to 190, or even round up to 200, depending on are we rounding to the nearest 10 or the nearest 100. Both would be up because 8's bigger than 5. In both cases, it's 8 we're looking at. The procedure involves place value. You need to know your place values. That's why we've learned them and nailed those down. Then you look at the digit. You inspect the digit that's right next to it. And I always use the hill, although it's not a great visual because we round up when you go over to the other side of the hill. And this looks like we go down, but anything on this side means we round up, and anything on this side means we round down. Okay, that means if it's 5 or more, we're still rounding up, even though 5 is technically in the middle. That's how we've agreed to do it. So, how do we do this? Book does it slightly different from me. I see the number 1,481,362. They say round to the nearest 1,000. So I like to circle the number they just said, 1,000. Okay, then I like to underline the number that tells me what to do. 3 was on this side of the hill, if you remember. So that's the down side. Now down really means stay the same, so I never change anything to the left of the place value. I could have written this part down before I even looked at the hill. 1,480,000. I never change it to 0. Right, I never move it down. I just keep it the same, and then I round this stuff down. Flatten it out. So technically, this number is worth less than it was before. And now I just realized I read something wrong. Nearest 100,000, not nearest 1,000. So let's do this again. 1,481,362. If it's 100,000, I did that on purpose so you could get more practice, right? That's this number. And the 8 tells me what to do. So this part stays. Now, is it 4, 5, 3? Never 3. We'd never go down from here. That wouldn't make any sense. Is it 4 or 5, though? The 8 tells me it's 5. We round up because it was on that side of the hill, so to speak. So always 0 out the rest, but this new number is worth more than this original number was, whereas when we rounded down, that number was worth less because the 3 was closer to the 1 than the 2. Well, in this case, 8 is closer to 5 than it is 4. So it's 1,500,000. We round up to that. Notice they circled the indicating digit. That's fine. But I like to make sure we're focusing on what number is going to either change or stay. And then I underline the number that's going to tell me what to do. If we round this decimal place, 3 and 14,159 10,000, I'd have to look again. But we're rounding it to 2 decimal places. That means that in my final answer, I will have 2 decimal spots. 3.1 something, right? That's 2 digits. Then this digit's just telling me what to do. So it's going to be a 0. 1. Now it's 4. That's my second decimal. Is that going to go up or down? down, or stay the same, I should say, because 1 is too small to round up. And you just zero out the rest, or don't even write it if they're trailing zeros. Hope that makes a little bit of sense today. If you have a fraction, you're just looking at, what do I do with this? Well, if the fraction is more or less than half. If it's half or more, then you round up. 5 is less than 12. So that means 13 stays, and we're done. Round to the nearest whole number. 0.512 is greater than 0.5, which is half, same thing, which means we're going to round up and make 13, make it 14.000. Okay? All right. To estimate means to find approximate value, whether it's estimating the length of the wall of your classroom in feet or the speed of the ball that was just thrown. And it can help us decide if something's reasonable without having to whip out a calculator. If Ivan wants to tile his kitchen 12 feet by 8 feet and a square foot costs $7.89, he's not going to be able to do that exact in his head, but he can get pretty close to know how much he needs to have in his wallet, right? So if it's 12 by 8, he might be able to do that in his head, or a quick punch in to find that that's 96 square feet. So 96 times how many per square feet? Instead of 789, we're going to use 8. And since 96 is so close to 100, and 100 is so much easier than 96, it might be appropriate to change that to just 100, means $800, might be a little off, might be a little high or low, but it's way different than his estimate. So no, we definitely can say, because of how different 800 is from $315.60, not a reasonable answer. If he was within even 100, I might give it to him. But he's way off. If you make almost $12 an hour, for quick calculations, we'll just call it $12 an hour. For 40 hours, if we want to know what he makes in a year, we'll take that, probably using a calculator, times how many weeks there are in a year, which is 52. Or we round the 52 down to 50, and instead of using a calculator, commutative says we can do this part first, 20, and then add those 2 zeros. Now multiply that by 12 again. You might be able to figure out that that's 24,000. You haven't used any calculator. Good for you. So about 25,000 per year. Okay? Did that without a calculator. You do one like that in letter G. And why don't you try H and I as well? We'll do some word problems today. What do you think about that?